7.4, solve linear systems by multiplying first. So same method as yesterday. It's just instead of us multiplying by like a -1, we'll now possibly have to multiply by some other numbers instead. For 3x minus 2y equals 3, and negative x plus y equals 1. So, I first am going to continue to look and see, is there anything that has the same number opposite sign? There is not. So now I need to choose if I want to get rid of x or y. In this particular situation, one of them is positive and one of them is negative on both. If there's like a sign that's already opposite, I'm usually going to choose that one. Both of these are opposite, so it doesn't matter. So do y'all want to do x or y? All right, we'll do x. So this is a 3 in front. This has a negative in front. So that means I need to multiply this entire thing by 3.
By -3.
No, by 3.
Oh, yeah.
Just let me teach. You don't know what you're doing yet. So copy the first one down. We have 3x minus 2y equals 3. And then distributing this 3 through everything, I have negative 3x plus 3y equals 3. 3x's cancel. Negative 2y plus 3y is y is equal to 3 plus 3 is 6. And then we take this and plug it into one of the original equations. So I would use the one that has y by itself, like there's nothing being multiplied by it. So I'm going to use this bottom one. So negative x plus 6 equals 1. Subtract the 6, so I have negative x equals negative 5. Divide by the negative, x equals 5. So then your answer is 5, 6. Six. 10x minus 9y equals 46. Negative 2x plus 3y equals 10. So do I have anything with the same number opposite sign?
No. Wait, no.
Nope. So I'm going to look then and I'm going to say, well, do I have anything with opposite signs already? Both of them are. So do y'all want to do x or y? All right, so this is a positive 10. This is a negative 2. So what do I need to multiply this bottom one by to give me 10x?
5.
So multiply by 5. So I'm going to copy down the top one. 10x minus 9y equals 46. Distribute this 5 through. Negative 10x plus 15y equals 50. And then combine it. 15y minus 9y is 6y equals, that's 96. Divide by 6. So y equals 16. And then I can take it and plug it into either of the original ones. Which one do you want to use? So negative 2x plus 3 times 16 equals 10. We're going to multiply negative 2x plus 48 equals 10. Subtract 48, so negative 2x equals negative 38. Divide by negative 2, x equals 19. So the solution is 19, 16. Yes, Taylor.
So do you on like the parentheses with the 5, do you multiply it by like 2 divided by 10? Do you divide 2 and 10 and then you get 5?
Which 10?
Like the 10x
This one?
and the 2x.
Yeah, so I'm trying to get these numbers to match. So I basically was like, okay, well, this number is smaller, so what can I multiply this by to give me 10? Sometimes, like, we're going to get into ones where you actually have to multiply both equations. So, but for right now, these ones you're just having to multiply one of them. Because sometimes it won't just be like, oh, I can multiply this by 5 and it gives me that number. But that won't always be the case. Other questions on these ones?
No, I think we did this before. I like vaguely remember doing this. I don't know.
I'd be very surprised if you had done this before.
I remember doing like this, but I don't remember doing the other two that we did yesterday.
I remember doing like elimination, like the linear equation.
It's possible, I guess. 10. Negative 2x minus 5y equals 9, and 3x plus 11y equals 4. All right, so does anything have the same number, opposite signs?
No.
Nope. Now, I do see opposite signs, so that's good. Can I do anything to the first equation to multiply it to make it look like the second equation, or vice versa? Nope. So we want to look for something that's like in common that we can use then.
You can multiply the top one by 3 and the bottom one by 2, so you both have 6.
Yep, so we're going to have to do both of them in this case. Now, if you want to do x, we can do what Drew said and multiply the top by 3 and the bottom by 2, because notice they have opposite signs. If they didn't have opposite signs, we would need to multiply one of them by a negative number. We also could have done the y's, and we could have multiplied the top equation by 11 and the bottom by 5, and that would have worked as well, but that's just bigger numbers. So I usually try to stick to whatever numbers are smaller. So top equation by 3, bottom equation by 2. So the top equation is going to be negative 6x minus 15y equals 27. Bottom equation is going to be 6x plus 22y equals 8. And now we have same number, opposite signs, so now I can simplify it down. So 22 minus 15 is 7, with the y obviously, and then 27 and 8 is 35. Divide by 7, so y equals 5. And then I'm going to take and I'm going to plug it into one of the two original ones. Now, you can use these that you've manipulated, but the numbers are obviously going to be a little bit more difficult because we've multiplied them and made them bigger. So, do you want to use the top or the bottom one? This one? All right, so we've got 3x plus 11 times 5 equals 4. So 3x plus 55 equals 4. Subtract 55. So I've got 3x equals negative 51. Divide by 3. So x equals negative, what is that, 19? No, 17. I was like, wait a second. And so then our answer is negative 17, 5. And remember, just like what we said with the last few sections, I can plug it in and check. Since I used the bottom one to solve to get it, I probably would recommend using the top one to check. Just so that you're not like potentially making the same mistake twice when you're plugging numbers in. But up to you. 12. 7x plus 3y equals negative 12. And 2x plus 5y equals 38. So, do I have same number, opposite sign on anything?
No.
Nope. So I need to choose one of them to multiply by, or both of them possibly if there's nothing. Now notice they all have the same sign, so I'm going to need to multiply one of them by a negative. I usually choose to do the bottom one just because I think it looks nicer, but it really doesn't matter.
Do -7 and then +2.
Yep. So we can do that. We could also do 5 and -3 on the y's, but we'll do what she said, 2 and -7, like this. So we'll distribute this. We've got 14x plus 6y equals -24. And then we've got -14x minus 35y equals, oh goodness, that's a big number. 56, 5.
114. Wait,
What? Am I going crazy?
I think I might have done something.
I think you did something.
Oh, I've been doing Y. Don't listen to me.
Okay, yeah, -266. I was like, Alright, so 14's cancel. So then I've got -29y equals -290. Divide by -29, so y equals 10. Yep. Alright, do you want to use the top or the bottom one? Alright, so we've got 2x plus 5 times 10 equals 38. We've got 2x plus 50 equals 38. Subtract the 50 over. 2x equals -12. Divide by 2. X equals -6. Notice I'm shortcutting the process by not showing like what I'm moving left to right. If you still need to do that, be my guest and do it. But if you're like, I can shortcut the process, then go ahead and do that as well. So I've got, the answer is -610. Questions on those? All right, I'm going to have you try this one on your own, and we'll see how we're doing. 14. 12x minus 7y equals -2, and -8x plus 11y equals 14. Now, actually, before you do this, the foolproof method is to do what we've been doing, okay, where I take, like in this problem, I see a 7 and a 2, and so I'm like, well, I know if I multiply them by the opposite number, that's going to work. So I multiplied this one by 2, this one by -7. I could have also done 3 and 5 to get rid of the y's, which I think is what Drew said he did. That's another option, okay? Now, when I get down here to one like this, I could choose to multiply this one by 8 and this one by 12, but that's going to be some really big numbers. Is there a smaller number that both of these things have in common?
24.
Yeah, 24. So, with 24 then, I say, okay, well, what do I need to multiply this one by to get 24? 2. And they're opposite signs already. What do I need to multiply this one by to get 24? 3. And so this is just a shorter method that you can use. Now, if you feel like you're going to struggle to pick those numbers out or you don't see that, you can always multiply them by the bigger numbers because that method will always work. Okay, if you multiply the top one by the bottom number and the bottom one by the top number, that always is going to work. But sometimes there's numbers that are actually easier to deal with that you're welcome to use as well. So you can either do it this way that I just wrote on the board, or you can do it whatever way you probably were going to do it before. That's up to you. So take a minute and just work through this one, and then we'll go over it. Are we at an answer?
1, 2, one, two.
We agree? Cool. So if you used, obviously I used the 2 and the 3 that I talked with you about. So then I got 19y equals 38. So y equals 2. And then I chose to plug it into the top one. Based on what y'all have been doing, I'm guessing you may have plugged it into the bottom one. Anyway, so that gave me 12x minus 14 equals negative 2. So 12x equals 12. And then x equals 1. Questions on that one? Do we need to see another one, or we think we're good? Okay. Well, it is because you've now seen the stuff from yesterday. Like, if I had done all of this yesterday, you probably would have been kind of confused.
Yeah.
So, just like the ones yesterday, there may be some where the stuff's not all on the correct side, so you may need to move it over to do it. So just watch for that as well. I'm trying to give you ones that give you all nice answers that are not like weird fraction answers and stuff. And not like weird problems. Actually, I want to show you one thing really quick just because it's a little trick that you've probably not, well, I may have shown it to you before, but I'm going to show it to you anyways. So, jumping down just for a second. 30 is x plus y equals 0, and 1/2 x minus 1/2 y equals 2. So, I'm going to show you a trick because I know we don't like fractions. So instead of multiplying the top equation by 1/2 and then canceling the y's and having all of these lovely fractions, we can do this pretty cool thing called multiplication. And I can get rid of my fractions altogether. So the top equation I'm going to leave. So x plus y equals 0. And I'm going to distribute this 2 across everything here. So 2 times 1/2 x is just x. 2 times negative 1/2 y is just negative y. 2 times 2 is 4. Y's cancel. X plus x is 2x is equal to 4. So x equals 2. And then I would use the top equation here. So I've got 2 plus y equals 0. So y equals negative 2. And so I've got an answer of 2, negative 2. So if you don't like fractions, and this will be helpful for other things, this doesn't just work when solving equations. But if you're like, man, I really don't like dealing with these fractions, if your fractions have a common denominator, or even if one of them's like 1/2 and one of them's 1/4, I can multiply the whole thing by whatever like the biggest denominator is, and it'll get rid of all of your fractions so you don't have to deal with them. So it's just kind of a fun little trick that a lot of times before I was teaching Algebra 1, people didn't learn until they were in like Algebra 2, and they're like, why did nobody teach me this? So anyway, so that can be another method that works for you. Some of these that we did up here where we were doing like the eliminating, I used to have teachers that would be like, use fractions and multiply by a fraction to make the number smaller. And I'm like, why? That's so much more difficult. So there's other ways you can do these, but I'm trying to give you the shortcut, easy way. Anyways, questions about that? All right, problems for you. We're going to go 5 through 15 odd. And then we're going to go with 21 also. So all of these should have nice, like, even answers, not like decimals and fractions in them. So 21 is going to be one where you're going to have to reorder the equation. So you can also on 21, the instructions say solve the linear system using any algebraic method. So that means you could use substitution or elimination, but y'all already know how I feel about substitution. So I usually use elimination, but it's up to you. So if it says any algebraic method, you can use substitution or elimination. If it says any method in general, you could use graphing, but again, I would refrain from using graphing unless I'm forced to.